Hello sir, we are here to give a presentation on artificial intelligence for recommendation systems. Our team members are Abhay Kumar Keshari 20 CS 10001, Shivansh Shukla 20 CS 10057, Vivek Jaiswal 20 CS 10077, and I, Likhith Reddy Morreddigari 20 CS 10037. These days, the data across the internet is too high, which when not managed properly, can't be used by an user. It is very difficult to filter out the things which are actually required from those available on the internet from such a large YouTube database. So we need to have a set of filtered out recommendations to choose from. The presentation is structured as follows. We begin with the introduction of the concept of recommendation systems, which is followed by a basic model and then background applications, revolutionary algorithms, and lastly we conclude with some thoughts on future works. Suppose a user is searching for movie in some OTT platform. As a movie platform, it has many movies and it doesn't want to randomly show some movies on its homepage because if none of them appeal to the user, then the user will leave the platform and shift to some other. So, what is the most logical way to show movies? Show the movies based on their previously watched, like disliked movies, their age, and other demographics. This is the beginning of the concept of recommendation systems. The basic idea is to collect data of users, data around users, and data across users to get an understanding of what users like or dislike. So, what is a recommendation system? A recommendation system is an application that is built to cope up with the problem of information overload and provide intelligent suggestions on items to users. What recommendation system does? It generates a personalized list of ranked items for users to buy from, where rank is computed from heterogeneous sources of data acquired from the user like interests, likes, dislikes, and demographics. Now move on to basic model. First, the user gives ratings, feedbacks, and asks queries to the recommendation systems, which are analyzed in different ways, and a set of recommendations are sent in ranked manner to the user. These are ranked based on the likes or dislikes and other features. The recommendation system is broadly classified into four categories: collaborative filtering, content based filtering, knowledge based recommendation, hybrid recommendation systems. What is collaborative filtering? These, these are based on the opinions of the members of the community. Next, content based filtering. These are developed at the assumption that items are with similar characteristics are related in similar ways. The next one is knowledge based recommendation, which recommends products based on the specific domain knowledge. Next is hybrid recommendation systems, which is the combination of all the above three filtering methods: collaborative filtering, content based filtering, and knowledge based recommendation. Background of the recommendation systems. The first analysis on collaborative filtering was in mid 1990s, and since then recommendation systems have become an important research area. There was an explosive growth of it in many e-services like e-commerce, e-business, e-learning during the period of 2000s and is still continuing. Nowadays, the recommendation system is a feature which is must so as to keep your users engaged with the platform. Some of the examples of these platforms are YouTube, OTT entertainment services like Netflix, Prime, and e-commerce websites like Amazon, Flipkart, and many more. Now I will hand it over to Shivansh, who will be further explaining about these things.
Hello, this is Shivansh Shukla, and now I will briefly explain the recent ongoing work on recommendation system in various fields of artificial intelligence. So, first we have transfer learning, which is a technique based on knowledge and reasoning. Next, we have reinforcement learning, which is based on reasoning and planning. Next, we have natural language processing, which is another technique based on communication and perception. And finally, we have computer vision, which is used for perception of images. Now I will explain each one of them in little more detail. So first we have transfer learning. So in the field of recommendation system, transfer learning extends recommendation requests from single domain to multiple domains by exploiting the correlation of several domains. So for an example, when an active user in a movie domain is interested in books and music related to movies they like, it can be used to solve the data sparsity problem, which is also known as cold start problem. Consider another example when a user may have only a few records in a book category service and rating system in an online review platform, but may have a large number of movie ratings. Hence, this availability of abundant data in other secondary domains can assist recommendation and provide worthy suggestions in the target domain. Now, let's talk about reinforcement learning. So the reinforcement learning technique used in recommendation system helps to increase the engagement and satisfaction of recipients in the long term. The technique analyzes the balance of exploitation and exploration. The direct implementation is to suggest the next product based on previous K consumed products. Moving ahead, we have natural language processing. Recommendation systems are popularly getting utilized in the movie and star rating domains. Many methods such as topic modeling and opinion mining have also been established in this domain of natural language processing. The goal is to connect these said two areas to extract information from the text and incorporate it into recommendation system process. The recommendation systems benefits from review informations they extract from natural language processing algorithms. Now we have computer vision. So the direct application of computer vision is used for recommending images in areas dealing with products and fashion analysis that are concerned with visual appearance such as images, jewelries and garments. The algorithm maps images and user preferences. The techniques take advantage of the features extracted from the images using deep neural networks and combine them with existing methods for clothing recommendation. Further, the extended research in this area has added features that would help to augment aspects of human vision system such as characteristics and color preferences into the framework. Now I will talk about evolutionary algorithms in recommendation system. Recommendation system provides several personalized service supports to the user by learning their earlier common practices and predicting the nature of their current preferences for particular products. Currently, AI techniques are making the recommendation systems more and more powerful. Some of these important techniques that have enriched recommendation system are deep neural networks, transfer learning, active learning, reinforcement learning, fuzzy techniques, and evolutionary algorithms. Moving ahead, evolutionary algorithms are a sub-area of AI research that form a class of nature-inspired population-based search algorithms for global optimization. An initial population or collection of potential answers to a problem is where an evolutionary algorithm begins. New solutions, often called offspring, are generated by applying genetic operators such as crossover and mutators to parent individuals. When the recommendation is viewed as a multi-objective optimization problem, evolutionary algorithms can be used to combine the outputs of various recommendation algorithms. They are also used to create user and item profiles and to manage ratings in the recommendation process. Now my friend Abhay will talk about evolutionary algorithms in further details. Thank you.
Hello, I'm Abhay Kumar Keshari. I'll be talking about evolutionary algorithms and recommendation systems. So broadly divided into three categories. These are multi-objective recommendation systems, evolutionary optimization of user item or profiles, evolutionary optimization of ratings. So further talking about multi-objective recommendation systems. So these recommendation systems are optimized using evolutionary algorithms, which take into account variety of performance indicators like accuracy, novelty, diversity, etc. So this is the most popular multi-objective algorithm. So this is a Topsis method algorithm. So this it has various steps. So the first step is to build a user profile. So the system gathers feedback from a target user to build his or her preference profile. Such preferences are conventionally associated with a scale values like degree of user preference for an item on a scale of 1 to 5 or 1 to 10. A user rating a movie A with 5 star and a movie B with 3 star. Therefore, it could be seen that it prefers A over B. Then user item matrix is constructed. Data relating to users and items in the system are entered into a user item matrix as a collection of numeric ratings, and then similarity measures are computed. So the similarity measures are users are calculated using the several common CF baseline methods. Following this, the top K users with the strongest correlation in terms of similarity with the target user are used to form the his or her neighborhood, and then we construct a decision matrix. So the attributes of k nearest users are collected and used to populate a matrix of alternatives comprising items that have been rated by the users but not yet chosen by the target user. And when then we apply the Topsis method to evaluate and rank all the alternative items. So it identifies the best alternative as one with the strongest shortest and the furthest distance with from the ideal and negative ideal solution. So the only input parameter are the weight values associated with the criteria, and then we generate recommendations, that is a list of sorted alternatives ranked according to the important measurement based on several criteria. In the final phase of the recommendation process, the top m items are selected and presented to the target user as a system set of item suggestions. So now further talking about evolutionary optimization of user item or profiles. In order to produce accurate recommendations, algorithm with an elite population to find the core users taken into consideration. So to address changing profiles, a dynamic recommendation system is developed, and that uses a evolutionary clustering algorithm to identify similar users and items. We can also have an interactive estimation of distribution algorithm in order to provide a recommendation to user in an interactive way. So one of the most common techniques is this technique, uh, interactive evolutionary computation with data grouping. So it has a further like many stages. So in the first stage is pre-processing. So the first step is feature extraction. So this is a technique that derives properties from specific data such as document, music, or photos. Extracting the features from the item is an essential step in context-based filtering method. Then the next step is data grouping. So data grouping algorithm like a k-mean clustering is used to improve the data efficiency in terms of accuracy and the quality of recommendation. And then we have a interaction with the user, that is user evaluation step. User can assign his or own rating score, which is the most exact way for users to represent their subjective preferences. After having the given items rated by the users, the proposed system evolves a population based on the evaluated data. Then we have a initialized population, and then we have further steps for the next interactive evolutionary computation step. So the first step is truncation selection. So here we use a truncation selection because the items rated lower scores by the users should not be considered to make recommendations. And then we have a crossover. The crossover is made to the selected items from the previous step. And then we have a matching step. So this step aims to calculate similarity between features of items resulted in the previous step and remaining items in the system. And then we have a newly generated population, and we substitute the weaker population with a newly generated population, and we have a new population, and then we evolve in this process. So talking about evolutionary optimization of ratings, Recommendation system use evolutionary algorithms to optimize various ratings. Technique of integrating multi-criteria ratings into recommendation system leverages more sophisticated user preferences. Like evolutionary optimization, multi-criteria approach supports decision making by aggregating a multi-objective optimization problem into a single objective problem by taking the multiple criteria as constraints. To handle the data sparsity problem, a genetic algorithm is utilized to optimize the weights of the domains to influence within the framework. Uh, Next, this is a summary of the evaluation algorithms. So they can be used to develop interactive, secure, and federated systems. To optimize models, federated learning can be used to reduce the communication overhead, and we can create secure systems. Those are less vulnerable to adversarial attacks. Next is similarity measures. So based on the method of implementation, we have two kind of methods. Memory based method that access the database directly, while the model based method that uses the transaction data to create a model that can generate recommendations. So memory based method are further divided into collaborative filtering and content based filtering, and model based system are further divided into regression and classification. So I'll be talking about collaborative filtering now. So the customers are compared with each another on the each product which with the target user or client has not yet engaged. Prediction functions are utilized to provide predicted rating, and then we produce the recommendation data to the target user.
Hello everyone, this is Vivek Jaiswal and I will be discussing about the content-based filtering. As you can see here, the recommendation engine depends upon the user preferences and as well as user feedback. And after that, the recommendation engine provides the recommendation to the web pages, which will interact with the user, and this cycle will go on. Now, model-based system. In the model-based system, develops a machine learning model to identify patterns in the previous data of the users and choose a parameter vector on the feature dimension to reduce the prediction error and as well as increase the accuracy of the prediction. This moderating problem can be solved by using regression or classification problem. Now the conclusion. In application areas, the use of recommendation system is expanding exponentially, which cause users to concern more about their privacy. In turn, this causes recommendation program to perform poorly because users are hesitant to input accurate and preferred information when using the system. The ability of evolutions multipurpose coverage enables the creation of applications for maintaining privacy programs. Although recommendation programs have had great success in the past, they struggle to handle the complex and dynamic characteristics of big data features. Time-aware recommendation systems are made to carefully consider this problem. In time-aware recommendation system, more techniques are being used to accept and user preferences on their models without noticing the fi- file flooding. We discuss a method for predictive weighting using an artificial neural network framework, where the model is trained using both collaborative and content-based features. This approach combines content, collaborative, and weighting-related metadata within a unified supervised learning model, producing more accurate prediction than many memory-based collaborative filtering systems. Though this research not just business geospatial data, but it can be crucial in creation of site-specific recognition scheme. We can find hidden object in review text using natural language processing techniques to rise the caliber of recognition. Many recognition systems face difficult privacy restrictions, especially when coupled with sophisticated artificial intelligence technique like deep learning or natural process programming. Now the last part of the presentation is the feature works. The focus of current implement in recommendation program is on the delivery of decision support for additional information related to object, image, social network, and user-provided VV metadata. We identify several areas of emerging research that will profit from future research on recommendation programs, given that recommendations are expected to always satisfy user needs while also helping to better understand what interests a wide range of users. These are some of our references. Thank you.